Okay, here we go. Continuity. Continuity of function f is said to be continuous if, or at a number, a, if the limit is x goes to a of x is equal to f of a. Now, some books write it like that, but I like to break it down into three separate pieces. There's a three-piece test that function has to pass in order for it to be continuous. You're going to have to memorize this for tests. Here's a stupid way of talking about continuity, but it's actually pretty smart. But this is a very non-mathematical way. If I could draw the function without picking up my pencil or pen, then it's continuous. But if I go to draw a function, I have to pick up my pencil to draw the function, then it's not continuous. Okay? That's just the layman's version of continuity. You got to pick up a pencil, discontinuous. Got it? Here's the mathematical approach. First of all, f of a must exist. So if you're wondering, is a function continuous at point A? When you plug a into the function, you better get a value, right? If you can't plug it in, you're in trouble. Like, for example, 1 over x minus 2. Where is it discontinuous? Yeah, we know it's discontinuous. You can't plug 2 in. Ugh. Was that a challenge? All right. Okay. All right. Second one, the limit as x goes to a of the function must exist. Do you remember how we talked about a limit existing? In order to check to see if a limit exists, it must be the same from the both sides, right and left, correct? So if you've got a function that's doing this thing, it's, I mean, f of a exists. You plug in a and you get a value. It's right there. But you can't draw it without picking up your pencil. And that means that in that situation, at least, not continuous. Because the left side is different than the right side, correct? And we have this last situation. The limit as x goes to a of the function has to be equal to f of a, which is what we wrote up above. So the limit has to be the same as the function value. So we'll give you this type of scenario. Does the function have a value at that spot? Does the limit exist? Are they the same? No. So therefore the limit is not, or therefore it's discontinuous. Okay, draw this picture. One in the black. Oh, backside. I'm sorry. Backside of your notes, you got all sorts of them. Sorry. I should have added this into your notes, and I forgot to. I'm redoing the lesson for tomorrow because it's not a very good one right now. So I should have redone this one. I did not. Bad teacher. I did spend time with my children, and I made supper. Sausage Alfredo. It's really good. Everybody got it? Okay, at letter A, it's discontinuous, correct? Which of the three does it fail? The first one, the second one, or the third one? Oh, don't do that. The first one, right? Because f of a does not exist. So therefore it fails. Number one. Does f of a exist? Does f of b exist? If I plug in b, do I get a value? Yeah, I do. Does the limit exist? No, so it fails too. The limit as x goes to b of f of x does not exist. So it fails too. Does f of c exist? If you plug c in, do you get a value? Yeah, we'll pick up when you guys get back. All right, here we go. This one fails because the limit does not exist. Why does the limit not exist? Because it doesn't feel like it. Thank you. Or because it's not the same as the from the left to the right. Yep. C. Does f of c exist? Yes. Does the limit exist? Yes. Is the limit the same as the output? No. So the limit as x goes to c of the function is not the same as f of c. So it fails number 3. We'll look at D. Does f of d exist? Does the limit exist? Is the limit the same as the output? So it's continuous. So you can see these are kind of the 4 case scenarios you might come up with regarding continuity. Are we okay with that? All right, let's just practice a little bit more. Turn back to this page. It says, using the graph at the right, identify the numbers which f of x is discontinuous. Identify which of the 3 requirements it fails to meet. Finally, identify the intervals for which it is continuous. Who can tell me where is the function discontinuous? For what x values? -5, 1, and 4. Those 3 values. Let's start with the easy one. Which of the 3 requirements does 4 fail to meet? First one, yep. F of 4 does not exist. So it fails number 1. How about 1? Does f of 1 exist? Yes. Does the limit exist? No. The limit as x goes to 1 of f of x does not exist. Therefore, it fails number 2. And -5, does f of -5 exist? Yeah, what is it? 3. Does the limit as x goes to -5 exist? What is it? 7. Are those the same? No, so it fails number 3. Does that make sense? Too much sense. Okay, so the intervals on which it's continuous, I guess we would say from -infinity to -5, but we would have an open bracket on -5 because, we got an endpoint there. And they would be continuous from -5 to what? To 1, but we would have an open bracket. And then from 1 to 4, and then from 4 to infinity. Sure, you could. Whatever. All right, flip over to the back page again where you drew some extra stuff. And please make this drawing. If you don't like it there, we can move it down. Give me a second to write that down. Again, I'm sorry, I was just telling teachers at lunch. I said, you know, all the lessons have pretty much been what I wanted them to be this semester for calculus, but so this is one that I've always wanted to change and I always forget to. So, oh well. Need some better examples, some yeah. We'll just have you draw them for today and I'll try to switch it for next year's notes. Pretty good? Okay. Is the function f of x discontinuous at a? Yes, it is. Which of the three does it fail? Number 2, because the limit does not exist. True or false? The function is discontinuous at b. True. Which of the two or which of the three does it not meet? 2. The limit does not exist again, correct? What is f of a? 1. What is f of b? 1. Okay. Now, here's something that it's not that big of a deal, but your book does ask a question on it, and I don't think that they ask this on the AP exam, but if they do, I just want to cover it. I haven't covered it in previous years. It's not that big of a deal. But if the limit as x goes to a from the positive of f of x is equal to f of a, then we say it's actually continuous from the right. If the limit is f of x, or limit as x goes to a from the left of f of x is equal to f of a, then we say it's continuous from the left. So I'll write that in here, continuous from right. Continuous from left. Again, sorry for the poor example. So you are correct in saying that the function is discontinuous at A and at B. However, we can have, just like we can have one-sided limits, we can have one-sided continuity as well. So we'll see if you can get this. F of A is 1. Is that the same as the limit from the left or the limit from the right? The limit from the right. So we would say that A has right side continuity, but not left side continuity. Does that make sense? Look at B. What is f of b? 1. Is that the same as the limit from the left or the limit from the right? From the right. So we would say that b also has right continuity from the right. Now, if I would change this and do that, then b would have continuity from the left. So the idea is that if you have an endpoint, you can have continuity from that side. And again, the definition is if the output is the same as the limit. If the output is the same as the limit. Does that make sense? Shaking your head? Yes, it is making sense. Or no, it's not. Okay. So let's approach from the left. What is this limit right here? Positive infinity from the left, correct? But the output is, what is f of a? 1. So because those two don't match, it can't have left side continuity. We try right. F of a is 1. What's the limit as x goes to a from the right? That's also 1. So since those are the same, it can have right continuity. But it doesn't have left because the limit is not the same as the output. Better? Okay. All right. Those two examples are important for just clarifying some questions. So now we should get back to these last examples here. You guys will understand these, I think, very well. We go to example 3 and example 4 in your notes. Generally, this test is one of the best tests of the year. I really want you guys to stay on top of your homework because I would like to test sometime next week and move on from this. So we would like to get to chapter 3 as quickly as possible. That's where a lot of the calculus really kind of takes its form for us. So got a lot of work to do in chapter 3. Explain why the function is discontinuous at the given number a. Sketch a graph of the function. X squared minus 4 over x minus 2. Somebody new second hour, see if you guys know. Do you know what this graph looks like or how we can figure out what it looks like? Very good. X minus 2, x plus 2, over on the bottom, x minus 2. But everybody agree that this function is discontinuous at 2. Why is it discontinuous at 2? Which one does it fail? Yeah, you can't even plug in f of 2, right? F of 2 does not exist. But here's what Sam does. He says, I can tell what it looks like if I simply factor it. Then what I do is I'm able to actually remove that discontinuity. So this wants to look like the graph of x plus 2. Now, who can tell me for an x value of 2, what value does the function take on or want to take on at that spot? 4. If you plug 2 in, 2 plus 2 is 4. So I'm going to have a hole at 2, 4. Is that clear to everybody? So you should be able to sketch the graph, show that there's a discontinuity at that spot, and then be able to describe which of the 3 it fails to meet. Karina already said that this one does fail, in fact, number 1. Because f of 2 does not exist. It's sufficient to write fails number 1, but I'm just going to, so that I can explain it, I'm going to write f of 2 does not exist. So everybody okay with that? We're going to come back to this example. It's very important as we do then example 4. But letter B here, I have a piecewise function. X plus 1 is a line that passes through 1 and is a slope of 1. If I plug in 0, what do you get for an output? 1, open or close circle? Open, and then I'll draw a slope of 1 from there. What does the square root of x look like? Yep, open or close circle at 0, 0. Closed. So we practiced graphing piecewise functions before. You should be able to do the same. Here's an example of those piecewise functions. True or false? F of 0 exists. True. What is f of 0? 0. So it satisfies condition 1. Does it satisfy condition 2? Why? Why doesn't the limit exist? Yep, different from the left and the right, so therefore it fails number 2. The limit does not exist. True or false? This function has continuity at 0 from the left. False. True or false? This function has continuity at 0 from the right. True. Good. All right, then our last example. It says the following functions have a removable discontinuity at a point A. Fill the discontinuity by writing a piecewise function. Here's what we're going to do. This has a removable discontinuity. A removable discontinuity is where you can see that hole, and it's like the function wants to cover that spot, but it doesn't because of this piece right here that we canceled off. So we already filled the discontinuity by showing that it had a value of 4 at that spot. So we're going to do the same thing down here. Would everybody agree this is discontinuous at -3? So our piecewise function will look like this. F of x is equal to, and we'll have x squared minus 9 over x plus 3 for values where x is not -3. So for everything except for -3, it's equal to that function. Now, if we were to graph that function, it would have a hole in it. We want to fill that spot. So at x equals -3, I need to know where we should fill that spot so that it will be continuous. So I will remove this. X plus 3 times x minus 3 over x plus 3. You can see that those cancel. So what does the function want to be at negative 3? It wants to be negative 6. So I wrote a piecewise function. The function will be x squared minus 9 over x plus 3 for all values not equal to negative 3. But at negative 3, we will have it be negative 6. That's your answer right here. Remember at the very beginning of this course, we said that we wanted to be able to find slope at 1 point. Slope at 1 point instead of 2. We couldn't do it. We had to set up P and Q, correct? By filling the removable discontinuity, that's the secret behind finding slope at 1 point. Okay? And so we'll see that in the next section. It'll make a little bit more sense, but this is what makes the calculus possible. So we had to go all the way through limits and continuity to get to that point. So does this factor, x to the third minus 1? Yeah, it does. It's the difference of two cubes, correct? So we have x to the third minus 1 over x minus 1, or x not equal to 1. I can plug any other number in there except for 1. Then when x equals 1, I want to fill that hole that was created. So I factor it. How is this factor? X minus 1 times what? X squared will be a positive 1, and I multiply the two together. X times 1 is x, and that sign is opposite the previous one. Take the cube root for that one, cube root for that one. Square the front, square the back, multiply the two to get the middle, and this sign is opposite that. That's the way I remember the difference of cubes. Yeah, here I'll do it again for you. So you have x to the third plus 8. Cube root, cube root, same sign. Square the front, square the back. Multiply the two together. This sign is opposite that. That's what I do every time. I taught it to you last year, but I remember it was a little bit of a blur, so it's okay. All right, so we get back to this point. We see that the x minus 1s will cancel out. So can I now plug in the 1? What do you get? 3. And that is what fills the gap. That fills the hole. How much time do we have? What time do we get out of here? Is it really? Okay, then I'll give you an assignment. I have the worksheet printed off for you. Yeah. Okay, oh, there it goes. So x to the third minus 1 divided by x minus 1. Okay, watch this. Oh, shoot. It's supposed to be right there. Oh, I won't do it. I'm sorry. I can't get the Zoom decimal to show up properly because it's just a little bit too high. I'll figure it out later. Okay, your assignment is... Nope, that's the other class. That's you guys. Oh, I just did that. Here it is. Section 2.5, page 110. Do number 3, which is a graph, kind of like we practiced earlier by just looking at the graph. And then 15 through 20, you have to be able to graph the piecewise function. You have to sketch a graph. I would encourage you to use your calculator if need be. That's what people struggle with here is being able to use a calculator properly. I'll hand out the sheets.